Cosmic Aerospace.
This is EP1, engine prototype 1. It's, as the name suggests, our first engine prototype, a full-scale system that goes into our airplane. So we're not only designing and building electric engines, but we're building full electric airplanes. It's the world's first electric engine that has the same performance as a normal aircraft engine.
This engine is composed of a lot of different materials, and all of it very focused on keeping it lightweight. This bell mouth and the case around the engine is made of carbon fiber composite materials, so they're very strong and very lightweight. Yeah, it's a hard question. I'm always thinking about airplanes, but...
You're listening to Bite Size Climate Tech, Season 3.
It's on now. This time, because we already have them on Season 2. Now, they're trying to design the aircraft so that make it work in the future. You can actually fly a passenger plane using batteries.
So our goal is to decarbonize aviation, and to do that we're going to use battery electric airplanes, partly because they have really high efficiency when you use batteries.
Now, Season 3, we're in the job conference.
This is EP1, engine prototype 1. As the name suggests, our first engine prototype of a full-scale system that goes into our airplane. So we're not only designing and building electric engines, but we're building full electric airplanes. So this was one of the first things that we've built to de-risk our technology. It's the world's first electric engine that has the same performance as a normal aircraft engine, which is pretty difficult to do electrically, because typically electric motors are heavier than gas turbines. We've basically shown that the technology now is ready to build electric jet engines in this way.
Does that mean that it's lower weight than normal?
The way you usually measure this is how much thrust can it make, how much can it push against how much does the engine weigh. So that thrust to weight ratio is a good way to see how good is this engine. And that's what we've recently matched conventional engines with our engine. And that allows us to now design an airplane around that that can go very fast, go very far, do it very quietly, actually.
Quietly? That's fun, because airplanes are so loud. So loud.
That's right.
Is there anything that we can...
So what you can see in this shot, this white case here and the fan that you see, this is the main engine system, but then we have other parts of the system that are embedded down here in the frame, in the test frame. So this test frame has several tasks. One of them is to keep the engine in place when it's full operation and generating all that thrust. We do have some measurements, some instrumentation on the engine to measure thrust and torque and other things. But then we also have some of the power electronics embedded in this test frame, which basically transfers the direct current that we're getting from the batteries into alternating current that we're feeding into the motor to power the fan. So, and then there's a cooling system in here that keeps the engine at the operating temperatures that we need.
If I can ask, how do you make this lightweight? Is there anything that you're doing in the thrust?
This engine is composed of a lot of different materials, and all of it very focused on keeping it lightweight. This bell mouth and the case around the engine is made of carbon fiber composite materials, so they're very strong and very lightweight. Various components inside the engine. The fan blades are made of titanium alloy, a very strong material for the high speeds that it's going. And there's also aluminum alloys inside the engine as well. So each part has its own role, and it has different trade-offs, and we try and choose the best material for each part.
How would you explain this to an 8-year-old?
Every 8-year-old knows how to annoy their sibling by blowing at them. And that's exactly what the engine does. It pulls in air with the fan and then blows it out the back with a lot of speed. It just does that 1,000 times more than any kid could do. So hopefully that helps.
Yeah, that's the thrust concept.
That's the thrust. The more you blow, the faster you blow.
Next segment is you answer a question from a previous guest.
Thinking about the technology that you're building, if you couldn't work in that technology anymore, what other technology within the climate tech would you like to be working at?
It's not an easy one. I don't know, maybe agricultural tech or something. Like that's something that, I mean, it's obviously a massive problem, and I think it's still a lot of potential there. So yeah, maybe that's something that I'd explore.
Yeah.
A hard question. I'm always thinking about airplanes, but I would go with agriculture as well. I've experimented with greenhouses and that kind of thing, and I think there's a lot of cool things you can do that way.
What's the question you will leave for the next guest?
So if there's one thing that you could change in your company, what would it be?
How you got to this conference and what kind of impact it has, and then what would be a better way to do that?
Last question. Why did you decide to work in climate?
I like the climate. It supports all of us, and I've got a couple of young kids who are going to inherit that
for the
from
future.
us. So
It's the biggest challenge that we have, and I think we do need to solve it. So that's one of the biggest motivations that you can have, and we want to do our part in solving it. So
Great.
let's make climate cool again.
Do a high five. Thank you. Thank you so much. It's fun. Can you come in here? Here.
all the way.
Yeah. You're out of frame.
Go on you.